In a world where you could calculate anything using calculus and physics, we were stupid enough to try and calculate the velocity it would take a car to go over a hill. Specifically, fly off this hill.
Well, how do we get here? Well, that requires a bit of physics, and a bit of physics is where we all like to be. Now, since this is a centripetal force problem, we know that we can set our force ma equal to mv squared over r, and then we need to figure out what exactly our forces come equal to, causing the car to go over the top of the hill and stay on the road. Well, in this case, it's only mg, because that's gravity is the primary force pulling down on the car to keep it on the road. So from there, we can begin to isolate v as the variable we're trying to find, and eventually we get to v equals the square root of rg. You may notice in this that g, while it be known, r is unknown, and we're going to need that r to solve for our eventual problem. Now, how do we come across this? Now, how do we get to r? Now, of course, for that, we're going to have to be a little creative and do a little trick. So what we did is we went up to the hill and we measured angles roughly at the same height across from each other, and they both came out to about 7.5. From there, we would put the 7.5 onto the triangle and made a triangle with it to the very, very, very top obtuse angle. From there, we figured, okay, if we could point towards the center of the circle from those 2 points, we would get our radius. So we basically made another triangle under it, set the top triangle and the bottom triangle under this from this picture, but it's supposed to be 90 degrees, and we figured out what that angle under it was. Then, since we knew the distance between the 2 points that we measured, we were able to do a bit of law of science action and figure out exactly how long the radius is. From here, we can plug things back into our original square root of r times g equation to get an answer of roughly 69 miles an hour. Now, granted, we did make a lot of assumptions, and we didn't, including the fact that these angles were they were a little bit different between them, and also the fact that they would have the same height. They were pretty close, but of course there's always a relative amount of error, and also this calculation does not account for drag, because I'm scared of that. Yes, so pretty close.
Well, that's it. That's how you calculate it. Now, as well-respected men of science, it's time for us to test our hypothesis. Let's do it. Thank you.